Warm up today, I'd like you to go ahead and evaluate this limit. It's very, very similar to one we did yesterday, but it was a tricky one. So if you need to follow with your notes, I think that's a great idea. Please pause the video here for 2 to 3 minutes to allow students to answer this question. All right, I'm hoping you remember the technique that we did yesterday. We started by setting this equal to y, because again, this is a 1 to the infinity indeterminate form. And then we took the natural log of both sides. So what I ended up with was the natural log of y is equal to the limit as x approaches infinity of the natural log of 1 plus 2 over x to the x power. But I'm going to move that x power out front following my log rules, okay? So now I have an infinity times infinity, an infinity times 0, and I'm going to move this x into the denominator. So the natural log of y is equal to the limit as x approaches infinity of the natural log of 1 plus 2 over x to the negative 1. Now I have a L'Hopitalable form. I have 0 over 0. And so I'm going to take the derivative of the numerator and the denominator. So natural log of y is equal to the limit as x approaches infinity. The derivative of the numerator is 1 over 1 plus 2 over x times the derivative of the inside, which is negative 2 over x squared, over the derivative of the denominator is negative 1 over x squared. My negatives divide out. My 1 over x squareds divide out. However, this 2 does not. And so I'm left with the limit as x approaches infinity of 1 over 1 plus 2 over x times 2. If I substitute my infinity, this term goes to 0, and I'm left with 1 over 1 plus 0 times 2, and that's 2. But if you recall, 2 is not going to be the answer. The natural log of the answer is equal to 2, which means that y is equal to e squared. This idea is going to be the foundation for our lesson today. But before we get into that, I want to give you a moment to check the answers to your homework. So here we go. Please pause the video here and ask each other questions until you're satisfied with the answers to this assignment. Okay. So you saw in one example yesterday, one homework problem last night, as well as your warm-up today, that some limits yield an answer of e or something related to e, a power of e or a multiple of e, even though they don't look like they would have an e in them, okay? And it's going to be helpful to recognize one common limit representation of E. It comes up on the AP exam a lot, and it's nice to not have to go through all that work that we did in the warm-up just to get our answer of E or E squared or something like that. So I would like you to memorize this, where A and B are constants. A and B are constants. The limit as x approaches infinity of 1 plus a over x raised to the bx is going to be e to the ab. The one we did in class yesterday was this, meaning both a and b were equal to 1. So this was just equal to e. The one you did in the warm-up A was equal to 2, B was equal to 1, and so the answer was e to the second power. This really is truly worth memorizing. I'm going to show you where it comes from, but at the end of the day, the more multiple choice questions you can answer in just a second, the better, and this is one that you can definitely do that with. Here's my proof. I have y equals the limit as x approaches infinity of 1 plus a over x raised to the bx. And again, we're remembering that a and b are constants. I take the natural log of both sides, which means I get the natural log of y is equal to the limit as x approaches infinity. Since I'm taking the natural log, I'm going to go ahead and move that bx out front. The limit as x approaches infinity. Oops, sorry. I got lost. The natural log of 1 plus a over x. I know that this is indeterminate, but it is not yet L'Hopitalable, so I'm going to move the x into the denominator. I'm actually going to leave the b up top. It's a constant. It's not going to help me. So this is going to be the limit as x approaches infinity of b natural log of 1 plus a over x over x to the negative 1. I can L'Hopital now. And I have b times the derivative of this, which is 1 over 1 plus a over x, times the derivative of the inside, which is negative a over x squared, over the derivative of the denominator, which is negative 1 over x squared. The negatives divide out, the 1 over x squareds divide out, and I'm left with natural log of y is equal to the limit as x approaches infinity of, I have a times b in the numerator over 1 plus a over x. As x goes to infinity, this term goes to 0. 1 plus 0 is 1. And this leaves me with just a times b over 1. But again, I'm not done. This is what the natural log of y is equal to. So y must equal e to the ab. There's my proof. And I'm just going to click through this. Sorry, I proved it on the slide. And that's actually it. So I would like you to copy down these 7 problems. These 7 problems are your homework for tonight. Some of these should look exactly like the form that I gave you to memorize. In fact, 1, 2, and 3, as well as 6 and 7 are exactly like that. However, 4 and 5 are a little bit different, okay? And so I'd like you, here's actually what I want you guys to do. This was a short lesson. I want you to spend all but the last 5 minutes or so of class working through these 7 problems. 1, 2, 3, 6, and 7 should probably not take you any time at all. 4 and 5 you need to do by hand. And then once you've done 4 and 5 by hand, I'd like you to come up with a rule for this type of representation. This looks different than the others. X is approaching 0 from the right. Your x is in the numerator. Your exponential x is in the denominator. I want you to come up with a rule for those. So pause to let everybody copy the problems down, okay? And then stop the video, let everybody work. And then in the last 5 to 10 minutes of class, I want to go over these and have you check your rule for numbers 4 and 5. Before you pause, you do have a quiz tomorrow on L'Hopital's rule and these E limits. Okay, so quiz tomorrow. On L'Hopital's rule and E limits. All right, pause to copy these down and then work until the last 5 to 10 minutes of class. All right, hopefully you got through those okay. The other way that you can represent e to the ab, this is the other rule that I'd like you to have memorized, is the limit as x approaches 0 from the right of 1 plus ax raised to the b over x. I'm hoping that's what you came up with. Okay, so have this memorized as well, please. Basically, instead of x approaching infinity, it's approaching 0, which is kind of like the reciprocal of infinity. And then we kind of take the reciprocal of x in this term and in this term. So basically where x was in the numerator, move it to the denominator, and as x approaches infinity, changes to x approaches 0 from the right. Here are the answers to 1 through 7. Please spend the remainder of class making sure you understand how to do these, and as I said, you have a quiz tomorrow on both L'Hopital's rule and these special E limits.